Hey everyone, we're going to be looking at systems today. I know Ms. Wise and Ms. Lynch are not in your classrooms right now, but you can learn. This is all Algebra 1 review for you. We're going to start with a quadratic linear system. Remember, a system is just two or more equations together. We're going to solve them. We're going to graph them both on this set of axes off to the right. And if you look at your two equations here, we've got the first one, y equals 2x plus 2.
And if you cannot graph that without your graphing calculator, shame on you. I'm just saying.
Right? Y equals 2x plus 2. What is that, Mrs. Wise? That's a...
that would be a line.
Okay.
All right. Definitely a line.
All right, so that's a nice line. We can start at our y-intercept of 2. Right? Y-intercept there is 2. And we also have a slope of 2 over 1. So we can...
Okay, so up 2 over 1. Up 2 over 1 to the right.
To the right.
Got it.
Positive.
Down, left, down, left. Yep, got it.
Okay.
No.
All right, so we've got y equals 2x plus 2. Please make sure that you label it with its equation because we are going to graph two things on here.
All right, next one. Parabola. How do I know it's parabola, Miss Lynch?
Because we've got the x squared.
Beautiful. Opens up or opens down?
Opens down because of the negative a value.
Got it. You were so good at this.
I know.
All right. Y-intercept.
Is 5. Y-intercept is 5.
Now, is it just magically 5? Why is it 5?
Because if you have an input of 0,
love it, input
of 0, you'll have an output of 5.
I like it.
So we have a nice 1, 2, 3, 4 y-intercept of 0, 5.
And we said we know it opens down.
Right, it does open
so we're
down.
feeling good about that. And y-intercept. And so we should be able to quickly find our axis of symmetry.
Good.
Right? X equals negative b over 2a. All right, and my a in this case is negative 1.
Right, so we'll have 2 times negative 1.
And my b in this case is 0.
Good. So we have an axis of symmetry of x equals 0.
So what does that tell me about my y-intercept in terms of like vocab?
So since my y-intercept is on the axis of symmetry, the point there, 0, 5, is actually our vertex, or turning point.
So actually 0, 5 is not only the y-intercept in this case, but I now realize it's also the vertex or turning point.
Good.
All right, and I know that it opens down, so I actually know everything is below 0, 5, right? Okay.
And then we can make a nice little table. We're going to put 0 right in the middle. And we can use our calculus really good.
Oh, you need a little help out there.
She's putting things way out of my reach here.
All right, so we have negative x squared plus 5.
Yep.
Got it.
Okay, so we go here, get a little table to fill in on our...
They can't see your finger right here.
I know. I can see it though.
All right, so we've got 0, 5. We have negative 1, 4, which matches up. We've got negative 2, 1. And we have 3, negative 4. So negative 2.
So you can plot those points now. Alright, so now when we plot this parabola, again, make sure you have arrows on the ends and you put your equation on there.
Got it. And so we're looking for the solutions, right? We want the solutions.
Right, we need the coordinates of the points.
Right, so you have the coordinates of the intersection at this point. It looks like negative 3, negative 4. And we've got 1, 4.
Okay.
All right, those would be our points of intersection, which again, we know if you make that connection, because we've been talking about this for a couple days now, all of the answers to your parabola, are sitting here, right? And all your answers to your line are sitting here, which means these points of intersection are solutions to both. That's the key, right? Those are solutions to both. All right, so we did that based on, okay, I got that. So now we are solving a quadratic linear system algebraically. So here we solved it graphically, right? Just talked about how that's solving it graphically, and now we want to solve this algebraically. All right, so no graph. We got to do this algebraically. So I would say, I don't know if Ms. Lynch would agree with me, I think, that since it's y equals, we don't want to necessarily do that add down or anything like that.
No elimination.
And it's not, on top it's not even linear, because you can even match everything up, because you've got a parabola here, technically, if you think about it as a graph, and you've got a line here, right? So we want to deal with our substitution, right? So we know that y and negative x are identical. They're exactly the same thing. So why does it matter whether I put a y there or a negative x? It doesn't, right? Because they're identical. They're the exact same thing. So if I plug in that negative x there, why does that make that better for me? Because now I got all x's. All right, so now my equation is?
Negative x minus 3 equals negative 2x squared.
Got it. And now we got this x squared. We want to solve this algebraically. We know we need to set equal to 0. I don't like this negative 2x squared. I never practice factoring with a negative 2x squared. So I am going to take that, I'm going to move it over to this side so it goes positive. So positive 2x squared minus x, that's staying there, minus 3 equals 0 now.
Good.
So now you know y is 0. So technically if we were doing this by a graph, we'd be looking on the x-axis. But we're going to do it algebraically. So we want to do this by grouping? I'm not grouping.
Mine do too.
Okay, so we'll group it. All right, we're going to group this. So there's no GCF, which means I multiply 2 times negative 3. All right, so I got negative 6. Multiples of negative 6. This one?
1 and negative 6. 6 and negative 1.
Oh, you're good. You're right on.
Negative 2 and 3.
Negative 2 and 3.
Negative 3 and 2. So the pair that are going to add to your negative 1 are going to be your negative 3 and 2.
Got it. We're going to use that for grouping because I'm sure Miss Lynch says this over and over in her class. If you're going to write something below it, it better be equivalent.
Yes.
Okay, so we've got 2x squared still, but now we're putting in negative 3x and positive 2x, which is still equivalent, because that gives me a negative 1, put the minus 3, and the equal 0.
Right, don't lose that. It's still an equation.
Because without that, they are not equal. Okay, so we got that. Now we're grouping. So we set ourselves up nicely for a group. Take a GCF of x out. Left with 2x minus 3. Hoping for a 2x minus 3 over here. Oh, there's already a 2x minus 3 over there. But I have to take something out. So what am I taking out?
Just a 1. So plus 1.
Plus.
Right, don't just put them right next to each other.
There's not a 1 there. It's not multiplication. Plus 1. 2x minus 3. Great, equals 0. You've got a new GCF right here. So x plus 1 times 2x minus 3. You already write it the other way. It doesn't matter. Okay, now you're factoring. Solving though, we got to finish. We are solving, not just factoring, we're solving. So, x plus 1 could equal 0, and then the whole entire thing would equal 0, which means x would have to be negative 1 for that to happen. Or 2x minus 3 could equal 0, add 2x equals 3, which means x could be 1 1/2 or 3/2. In either case, if you put in negative 1 in for x into these, the whole thing will equal 0. If you put in 3/2, the whole thing will equal 0. All right, am I done?
No.
Oh, not done. Okay.
Nope.
Got to keep going because we have to find
Y values.
y values. All right, so when x equals negative 1, in other words, when we input negative 1 into one of those equations, we want to get our output. What's happening? Now, which one do you want?
I much prefer that line.
Yeah, me too. Way easier. All right. So y equals negative x. I'm going to pick. You all want to pick that. Have fun. All right. So now I take negative 1 and input it. So y equals negative 1, which is really
1.
Y equals 1. All right. So graphically, if I was looking at this, just as something to think about, graphically, if I was looking at this, the point would be negative 1, 1, right?
Right.
Where they intersect. Okay? And so that's my solution. When x equals negative 1, y is equal to 1. Or you can write it out individually. All right, and then we've also got to do the same thing when x equals 3/2. And I would pick the same equation. Makes that a lot easier. So y equals negative 3/2. Oh, boom, I'm done, right?
Yep.
There it is. Okay, and that means my coordinates are positive 3/2 and negative 3/2 would be my other point of intersection, which would be the solution. So these should be my two solutions and should work in both of these.
Right.
And again, if you want to double check, store key is phenomenal. This very expensive $100 graphing calculator,
Yes.
right? Use it. Beautiful. All right, moving on. We know you miss us.
I know.
It's all right. We're coming back.
All right, so now let's bust out those calculators. We're going to use them for this problem. So we're solving our quadratic linear system just using our calculator. Okay, so we're going to let our calculator do the graphing to come up with our points of intersection. So in order to go to our calculator, make sure you get both equations. The top one is your parabola. Bottom one is your line, but you want to make sure it's into y equals form. So add your 5x to both sides. We get y equals 5x plus 5. That's our line.
Right, so we're just giving you a different technique here. You've got 3 different techniques. Remember we talked about you should be able to do things with equations, lines, graphs. This is just giving you different ways to solve systems.
All right, so we've got both equations now in y equals. Go to your calculator, and we'll need to put those in. So clear that out. Y equals 2x squared plus
4x minus 1.
Good.
And you wanted y equals positive 5x plus 5.
All right. So if we graph these now,
or let the calculator graph them for us so we don't have to bother.
I want to see those 2 points of intersection.
All right, so we don't see both points of intersection. So what can we do to fix that? It looks like it's not that far above, so we probably could just go to our window, because that's what we're looking at, and maybe change our y max to 20 to be sure.
Right.
Probably could do less than that, but we can try 20. Now if we look at the graph,
Hopefully we'll see those 2 points of intersection. And
now we see the 2, which we need in order to use our calculator.
Right, so we're looking for the coordinates of both of those points. So if you follow the directions on that page, we're going to hit second, trace, and we're looking for intercepts. You want to do number 5. All right, you find 1 point of intersection at a time. All right, so unlike the other day where we were doing left bound, right bound for our zeros, this one's asking us, are we close to it on our first curve? So you can see my cursor is blinking on the quadratic. So I'm going to move it over closer to the point of intersection. Doesn't have to be exactly there, but really close. Hit enter.
You did a great job there, Ms. Lynn.
Thank you.
Thank you.
Looks like it is exactly right
If
there.
you guys can do it that good, I don't know. I think that's phenomenal.
And then it goes to second curve. So now it's on the line. It's actually going to stay right there. So you're good. Hit enter. We don't guess in here. And there's my point of intersection. So negative 1.5, negative 2.5. Let's go back and write that for ourselves.
So you've already got that x and that y in one step, which is nice.
Negative 2.5.
And negative 2.5, yeah.
All right, so it gives you the coordinates x and y of that first point of intersection. And now you just go back and repeat the process for the other point. So second, trace number 5 again. Go on over closer to that point. All right, enter. Second curve, it stays right there. And now we get the other point of 2, 15.
A little nicer.
Yep. Okay, so these are the coordinates of your 2 points of intersection. This is great if you're doing a multiple choice question. You want to go through and just check on your calculator the ones you've already done algebraically, so you can use your second trace intersect function to be able to come up with those coordinates.
Right, so you should never get it wrong unless you can't figure out what you did wrong.
Right.
You should be able to double check yourself. All right, last one here. Okay, so we are still solving graphically this time. Okay, but what's the difference here? The difference here is, okay, I got a parabola, which I've had every time. That's fine. I got a parabola. But then the second one, I also have a parabola, which is fine because when you're graphing, you're still graphing all the solutions to this equation. It just happens to look like a parabola. And all the solutions to this equation, which just also happens to look like a parabola. Non-issue. I would say I get it. You can go right to your graphing calculator, type this in and get a table, and you can get a table for that one. But let's just try to you could draw a rough sketch here, right? Get an idea what you know about this so far. So you know it opens.
It opens down because of the negative a.
Opens down. We know that that means it has a max or a min.
It has a maximum.
Max. We know that our y-intercept is what?
4.
4.
0, 4.
So 0, 4. And very quickly, just to double check, negative b over 2a. So I got x equals, negative b is 0, 2 over negative 1, so x equals 0.
Good.
And then, of course, 0, 4 then means that it's my turning point, and it happens to be my y-intercept. Okay? So, and you know it opens down. So really, honestly, you don't even need a graph calculator, I don't think, if you plugged in 1 for that one. Maybe be careful of this little negative out here. So if I filled in 1 on this, like f of 1 basically, you'd have negative, you fill in your 1 squared plus 4. All right, what's the issue here, Miss Lynch? Where did we mess up?
So you're gonna square the one first. Exponents happen before you multiply by the negative one.
Good old PEMDAS. So we got 1 here squared, and then we negate it. That gives us negative 1 plus 4, so f of 1 is actually 3.
Good.
Okay, so
because it's symmetrical.
Yeah, symmetrical. We're pretty much done, right? Should we plug in and find the roots or not bother?
Well, let's just do
Alright,
one
let's
more.
do
We do
it.
one more.
Alright, so let's just fill in f of 2.
2.
We won't even deal with the negative 2. So negative, you fill in your 2, you square it, fill in 4. So again, PEMDAS says you should be doing that first, which gives you 4. You negate it. 4 plus 4. Oh, there's my 0 I was looking for. So 2, 0 is one of my x-intercepts. I go to 2, 0, I plot it. Symmetry says negative 2, 0 is going to be another one.
That's beautiful.
That is nice. Might not be perfect. We'll see if we have to extend, we'll extend. Okay. So now label. We got y equals negative x squared plus 4. Got it. All right. Next one, we're going to go to graph calculator?
Sure.
Should we do it again?
No,
Yeah,
let's give him a break.
graphing calculator. All right, we'll give you a break this time. All right, so we're going to go right to our graphing calculator, and we'll figure out, hopefully we'll find our axis of symmetry quickly. If not, we'll plug it in and find it so we know what we're looking for. X clear. All right, what do we got?
X squared minus 4x
minus 4
plus 4.
Plus 4. And table.
Yeah.
All right, so what are we looking for in here so we can find that middle?
Looking for those repeated values of symmetry.
So this one's nice.
Right.
Non-issues here. Okay, so it looks like we got a, oops, let me get the option. Looks like we've got a 16, 25, that looks nice.
Yep.
That puts 2, 0 as our turning point.
So an axis of symmetry of
Right, we
x
got those,
equals
so
2.
We can write those down. 2, 0 is our middle.
Yep, and then it's 1, 1,
1, 1, 3, 1,
0, 4,
0, 4,
and negative 1, 9.
9, 9. Okay, so we'll go with oh, purple? Oh, here. Of course we did purple. I don't know what I was thinking.
We started
with
with purple.
because Lynchy was using the remote here thing. All right, so negative 1, 1, 2, 3, 4, 5, not gonna fit, right?
Nope.
Okay, 0, 4. Boom, we got it. 1, 1. Here it is. 2, 0. Got it. 3, 1. There it is. And 4, we're here. So here's my sketch. Alright, so we've got y equals x squared minus 4x plus 4. Again, it doesn't matter whether it's parabolas. You guys are getting good at this stuff now. This is all solutions. Purple one's all solutions to the first one. This is all solutions to the second one. I'm looking for solutions that work for
Both of them.
Alright, so what are going to be my solutions that work for both?
Looks like 0, 4,
0, 4,
and 2, 0.
and 2, 0. And if you wanted to check, you could easily store 2 for x. Store 0 for y, although you don't have to because it's going to be here. So store 2 for x and then see whether it gives you 0. Store 0 for x and see whether it gives you 4.
Good.
All right, so for the homework, we gave you some of each. Make sure you're following directions. If it says solve algebraically, make sure you solve algebraically. If it says solve graphically, make sure you're graphing an accurate graph. And then the other ones are using your calculator like we did to find different pieces.
All right, so you're starting here below on number 1, and you're finishing, looks like, to the page of 21.
21. All right, have a great day.
Enjoy your weekend.
Yes. See you later. Bye.